Hello students, I'm Dr. R. Krishnakumari, Assistant Professor, Department of Mathematics, Faculty of Engineering and Technology, SRM Institute of Science and Technology, Kattangulattur. Today we are going to see about Laplace transforms and inverse Laplace transforms. Laplace transform is a mathematical tool which enables us to solve differential equation by the use of algebraic methods. This transform was first introduced by Laplace, a French mathematician. So this Laplace transform belongs to the family of integral transforms, the solutions of mechanical or electrical problems involving discontinuous force functions are obtained easily by using this Laplace transforms. Definition of Laplace transform. Let us consider f of to be a function of the variable t which is defined for all positive values of t. Let s be the real constant. So if the integral 0 to infinity e to the power of minus st f of t dt exists and is equal to f of s, then this f of s is called the Laplace transform of f of t and it is denoted by the symbol L of f of t. The Laplace transform of f of t is said to exist if the integral converges for some values of s, otherwise it does not exist. Hence the operator L is called the Laplace transform operator which transforms the function f of t into f of s. We have to remember that limit s tending to infinity f of s is equal to Laplace transforms of standard functions. So these are some standard functions for which the Laplace transform is represented here. So Laplace transform for e to the power of minus at is going to be 1 by s plus a and e to the power of at is going to be 1 by s minus a, where s going to be greater than minus a as well as plus a, and the Laplace transform of cos at is going to be s divided by s square plus a square, and for sin at it is going to be a divided by s square plus a square. And while in the case of hyperbolic, the symbols in between, that is the plus and minus, are going to that is for Laplace of cos h at is going to be s divided by s square minus a square, and for sin h at it is going to be a divided by s square minus a square. Laplace transform for 1 is going to be 1 by s, since Laplace transform for t to the power of n is going to be n factorial divided by s to the power of n plus 1. So these are some standard functions that are used for solving sums based on Laplace transform. Now let us see certain important properties of Laplace transform. The first property we are going to see is about linear property of Laplace transform. L of t plus g of t is going to be equal to L of f of t plus g of t. Similarly, L of f of t minus g of t is going to be L of f of t minus L of g of t. And L of k f of t is going to be equal to k L of f of t, where k is a constant. The next is going to be first shifting theorem. So if L of f of t is equal to f of s, then L of e to the power of minus at f of t is going to be equal to f of s plus a. And if L of e to the power of at of f of t is going to be equal to f of s minus a, similar to that of e to the power of minus at. The second shifting theorem is going to be that if L of f of t is going to be equal to f of s, and g of t is equal to f of t minus a, where t greater than a, otherwise 0 if t is less than a. So this is going to be the second shifting theorem. And the next property is going to be chain gauge property. If L of f of t is equal to f of s, then L of f of at is equal to 1 by a f of s by a. Now let us see a sum based on Laplace transform. So find the Laplace transform of cos cube t. So we know the formula for cos 3a is going to be 4 cos cube a minus 3 cos a. So bring the cos cube a to the LHS. So it is going to be equal to 3 by 4 cos a by 1 by 4 cos 3a. Laplace on both the sides, we will be getting Laplace of cos cube t is going to be equal to 1 by 4 Laplace of 3 cos t plus cos 3t. So applying the standard functions for cos at, we will be getting the answer as 1 by 4 3s by s square plus 1 plus s divided by s square plus 9. Similarly, let us see another sum, Laplace of sine 3t cos t. So here we are going to apply the formula, trigonometric formula, sine a cos b, which is going to be equal to 1 by 2 sine a plus b plus sine a minus b. Hence, for sine 3t cos t, it is going to be 1 by 2 sine 4t plus sine 2t. So when we are going to apply Laplace on both the sides, we will be arriving at the answer as 2 divided by s square plus 16 plus 1 by s square plus 4. Find the Laplace transform of f of t equal to e to the power of t when t lies between 0 and 1 and 0 when t is greater than 1. So by the definition of Laplace transform, we know that L of f of t is going to be equal to 0 to infinity e to the power of minus st f of t dt. So here we are going to, since t lies between 0 and 1, we are going to apply the limits as 0 to 1 e to the power of minus st f of t dt plus 1 to infinity e to the power of minus st f of t dt. So in the place of f of t, we are going to put et, since in the question they have given that f of t is going to be equal to et. Therefore, we will be getting it as 0 to 1 e to the power of minus x plus 1 t dt. When we integrate this with an upper limit as 1 and lower limit as 0, we will be getting the answer as 1 divided by 1 minus s e to the power of 1 minus s minus 1. Laplace transform of derivatives. If L of f of t is equal to f of s, then L of f dash of t is equal to s of L of f of t minus f of 0, and L of f double dash of t is equal to s square L of f of t minus s f of 0 minus f dash of 0. So we have to note that under certain condition, the process of this Laplace transform replaces the differentiation by multiplication by the factor s and s square represent respectively. So in general, we used to tell this as L of fn of t is equal to s power n of L of f of t minus s n minus 1 f naught minus s n minus 2 f dash of 0 up to f n minus 1 of 0. Laplace transform of integrals. If L of f of t is equal to f of s, then L of integral of 0 to t f of t dt is equal to 1 by s L of f of t. So we have to note that the above result expresses that the integrals between the limits from 0 to t is transformed into simple division by the factors using Laplace transform. Now let us see few sums based on Laplace transform. So find L of integral of 0 to t e to the power of t sine h 2t dt. So L of 0 to t e to the power of minus t sine h 2t dt is going to be equal to 1 by s L of e to the power of minus t sine h 2t. So when we are going to apply the shifting property, we will be arriving at the answer as 1 by s 2 divided by s plus 1 the whole square minus 4. Similarly, we can solve for this sum also. So L of 0 to t sine 3t cos 2t dt is going to be equal to 1 by s L of sine 3t cos 2t. So which is going to be equal to 1 by 2s L of sine 5t plus sine t. So when we are going to apply the standard functions of Laplace transforms, we will be getting the answer as 1 by 2s 5 by s square plus 25 plus 1 by s square plus 1. Initial and final value theorem. So if L of f of t is equal to f of s, then limit of t tending to 0 f of t is equal to limit of t tending to infinity s f of s. Similarly, if L of f of t is equal to f of s, then limit of t tending to infinity f of t is equal to limit of s tending to 0 s f of s. So in this sum, we have made use of the initial and final value theorem. So here we have made use of the initial and final value theorem for the question f of t is equal to e to the power of minus 2t cos 3t. So first we have used the shifting property and we have found out that capital F of s is equal to s plus 2 by s plus 2 the whole square plus 9. So by using the initial and final value theorem, we arrive at the answer that a limit of t tending to 0 f of t is equal to limit of s tending to infinity s f of s, and limit of t tending to 0 f of t is equal to limit of s tending to 0 s f of s. Inverse Laplace transform. If the Laplace transform of a function f of t is f of s, that is L of f of t is equal to f of s, then f of t is called an inverse Laplace transform of f of s, and it is denoted in such a way. Here, this L inverse is called the inverse Laplace transform operator. So these are some standard functions of inverse Laplace transform. Here I have showed it as a comparative results for how L of 1 will exist and how L inverse of 1 by s will exist. So similarly I have showed the comparative results for all the Laplace transform and inverse Laplace transform. So these are some standard functions that we make use in our problems. Yeah, so these are also going to be the standard functions. So I have shown both Laplace transform and also inverse Laplace transform here. Next, we are going to see about some important properties of inverse Laplace transform. So these four are the important properties of inverse Laplace transform. So they are linear property, first shifting theorem, second shifting theorem, and change of scale property. So if Fn of s and F2 of s are Laplace transforms of F1 of t and F2 of t, then L inverse of C1 F1 of s plus C2 F2 of s is going to be equal to C1 L inverse of F1 of s plus C2 L inverse of F2 of s. Here C1 and C2 represent the constants. So this theorem is said to be the linear property of inverse Laplace transform. Next, we are going to see about the first shifting theorem. So, if L inverse of f of s is equal to f of t, then L inverse of f of s minus a is going to be equal to e to the power of at L inverse of f of s. Similarly, if L inverse of f of s is equal to f of t, then L inverse of f of s plus a is going to be equal to e to the power of minus at L inverse of f of s. Similarly, for the second shifting theorem, if L inverse of f of s is equal to f of t, then L inverse of e to the power of minus as f of s is going to be equal to f of t minus a u of t minus a. Here u represents the unit step function, and the last is going to be change of scale property. So if L of f of t is going to be equal to f of s, then L inverse of f of as is equal to 1 by a f of t by a, where a should be greater than 0. Now let us see a sum based on inverse Laplace transform. So we have to find the value of L inverse of 1 by s into s square plus 6s plus 13. So here I have shown the solution. So first I have just simplified the quadratic equation, that is s into s square plus 6s plus 13, that we have just simplified in the form of a plus b the whole square. So if I'm going to simplify in the form of a plus b the whole square, I'll be getting plus 4, and after that I have applied the formula, and when simplified I have got it as minus 1 by 26 e to the power of minus 3t 3 sine 2t plus 2 cos 2t minus 2. So this is also a sum similar to the previous one. So here we are going to solve L inverse of s square by s minus 1 to the power of 4. So by using inverse Laplace transform standard function properties, we are able to arrive at the solution of t e to the power of t plus e to the power of t square plus t cube e to the power of t by 6. So here we have used the properties of shifting theorem. So this is also a similar sum, similar to the both the sums which we saw earlier. So here also we are making use of the first shifting property, and by making use of the shifting property we are able to arrive at the answer. Thank you, students. Let us join again in another interesting session. Thank you.